So again, the name of this webinar is CodeJumper Outcomes, Exploring the Assessment Tools in the CodeJumper Curriculum. And joining us today from the state of Washington is Robin Lowell. She is the Senior Manager of Accessibility at I2E. I believe she's also moonlighting in the classroom right now as well, correct, Robin? Yes.
Correct.
And has a daughter that is headed home from college here momentarily. So they're going to go from a household of back from 4 back to 5. Yes.
Yep.
May the 4th be with you.
Thank you.
And then we've got Beth Dudycha, who is coming to us live and in stereo from the land of 10,000 lakes from up in Minnesota. She is the Senior Manager, Content Development at I2E. Welcome, Beth. Thank you for being here.
Thank you.
All right. So as we get started, we typically talk a little bit about challenges. So if you are using CodeJumper and you are using the CodeJumper curriculum, or you are working with a computer science curriculum, you may have a difficulty identifying expected outcomes from the curriculum, the lessons, or the tools that you're using. You may be challenged with a lack of structure in the lesson plans, finding helpful resources, and evaluating student progress. And what we are hoping to do today is to help you with some of those challenges that you might be experiencing with CodeJumper, or to give you some insight into some things that you could be doing with some of the other tools that you're using. Our learning objectives specifically are to explore with you the assessment and data collection materials that are available in the CodeJumper computer science curriculum. We want you to discover how to use the 2 levels of assessment that are available in that curriculum. We will identify 4 strategies to document learning while using CodeJumper. And then finally, we will discuss how to implement and use a computer science journal. And I believe that is it. So I am going to stop sharing right now. And I am going to mute myself and invite Robin and Beth to get started.
Awesome. Thanks, Sully. Okay, so I'm going to start. I'm going to share my screen so we can, oh, good. We're all good to go. Here we go. So, well, welcome everybody. We're super excited to be here and talking to you about the assessment portion of CodeJumper. As Sully said, I'm Robin, and my wonderful co-presenter is Beth. So let's get started. Okay, so Beth, take us away.
Yeah, so excited to be here. So CodeJumper is all about teaching computer science and coding. And coding is a very important skill we want all of our students to have so that they can engage in the world around us. So much about computer science is about developing computational thinking skills, problem-solving skills. There's a lot of resilience in coding, learning how to fail at things in a safe space, which is an excellent practice in CodeJumper. There's a lot of fails, and there's some funny things that happen when you fail in CodeJumper. There's a lot of creativity in coding. We want students to be able to engage and create content in the future. So they need to have these skills to understand how it works, so that when they get a job someday, they will be able to inspire everyone else with their creativity. Lots of collaboration and communication is required in coding. And there's just a lack of these skills in general. In the general population, there are not enough students getting degrees in computer science, and it is a need that keeps coming up in our everyday lives more and more. So a very important thing, and CodeJumper is a great way to learn about computer science and learn some of these skills. All of these skills are covered many times over with CodeJumper. So how does CodeJumper work? Robin?
Well, we're glad you asked. Yes, so how does CodeJumper work? And let me describe what's happening on the screen right here. So we have this little critter, and their name is CJ, and we have a whole series of puzzles that you can use as well. And so CJ is now the face of CodeJumper. And so Beth is holding up an amazing little actual plush toy 3D version of CJ with a little play pod. CJ is the turquoise color with these very expressive orange eyebrows, big eyes, orange tipped ears, and a tail that kind of looks like a raccoon tail. So it's striped orange and blue. It's pretty fantastic. So how does Code Jumper work? So Code Jumper really is, so it sounds like everyone has a pretty much a basic understanding. So it's a physical coding language that students can put pods together. I'm going to bring up my picture of and what we have going on here. So it's a physical coding language where we have a hub, which I'm going to describe, which is the biggest pod, where we have a play button and a stop button. It's actually a Bluetooth speaker that we physically connect the mouse-shaped pods to. We have two that we're going to be using today, which is the play pod, which plays the sound because Code Jumper is sound driven. And the play pod is the shape of a computer mouse with a port on one end and a cord coming out of the other. And on top are two dials, a short, flat, donut-shaped dial that has ridges around it, and a tall dial that has vertical ridges on it. The flat shape changes our sound, and the tall ridged one changes the speed of the sound. And then we have also a loop pod, which is white and yellow, also shaped like a computer mouse. But this one has one dial on top, which is flat and yellow, with some indents ridges on it to indicate that this is the loop pod. And we have one cord coming out, which is attached to the hub. And then on the one side of the hub, we have a long cord, which attaches to a play pod or another type of pod. And then two ports, one to complete the loop, and then one that comes out of the end to continue on our program. So that's just a basic description of the components that we're going to be using today. So again, this is a physical coding language that students with any level of vision, it's the most collaborative tool I've seen in all my years for helping students really learn about coding. So that's just the basics of Code Jumper and what we're going to be seeing today. Okay, so Beth is now going to tell us about, we need to learn about how do we record Code Jumper progress. So Beth, tell us why we need to worry about that.
Well, we're teaching all of those skills that I talked about earlier, right? We want to make sure our students have the thinking skills behind computer science so that they understand how to engage in other areas of life with computer science. We want them to develop those computational thinking skills, but we don't want to just play with a toy. This is far beyond a toy. And so we want to make sure that our students are not just engaging at that surface level. We want to make sure they're understanding the concepts. And to do that, we need to gather some information about what they're doing with Code Jumper so that we can evaluate as educators whether they're getting it or not. Are they understanding the concept of that lesson? Are they stuck somewhere? What's hanging them up? Are they having trouble with a certain area or not? And so there are lots of different ways to do that. Within each lesson, there are opportunities for assessment. Every single time a student engages with Code Jumper, there is an opportunity for assessment, but it's probably not going to look like a multiple choice bubble sheet. It's going to look a little different. And so in the entire curriculum, in every lesson, I believe, there is an opportunity for students to write in a computer science journal. Code Jumper does not save, as you saw a second ago in the app. The app does not save. It forms with whatever is connected to the hub and is changing all the time. So the minute you turn it off, all of those lines of code, and Robin has the app up on half the screen here, those look lovely for now, and you could save a screenshot of that, which is a really simple way for students to capture what they created. Because the minute they take it apart and put it back in the box, it's gone. So screenshots and photographs are pretty simple ways to capture the physical aspect of what's happening in Code Jumper. Also, the computer science journal, sorry, I was starting to go down that path. Having students record, and this can look lots of different ways. This can look like just a piece of paper. Maybe this is something they do on a device. Maybe this is something that you have created a format for where students can just fill in pieces of it. And video recordings are also great. But all of these would give us an indicator, and if we collect them as we go with the lessons, we can evaluate whether they're ready to move on to the next lesson, or before they do, we're going to get into this in a second, the primary or the advanced assessment, larger assessments, before they're ready for that, kind of check and see if they've gotten these smaller pieces along the way, some formative assessments along the way. And we're going to go into that in a moment.
Oops. But first, we have our first poll question. So our question is have you used the assessments built into each Code Jumper lesson? Yes, no, or you were unaware that they existed?
All right, well, our audience is responding, and we will take a moment to share those results here as soon as I can find the end poll button. And I found it.
Yes, no, or unaware.
All right. All right. So the vast majority of folks who are participating are saying no. There are a few people that are saying that they were unaware that they existed, and then just really a couple of you were saying yes, we are using that. So there you have it. The majority would be saying no, or that they were unaware that they existed. So we'll be doing some learning today then.
Sounds great. Then we're all here for a reason.
Yeah.
All right. So where do we find this? We actually have opportunities built throughout the lessons, as Beth said, and the assessment. So where we're going to start first is looking at one particular lesson. And so we have these basically in the same spot in all of our lessons. So we're just going to dive into one to begin with and look at where the different pieces are and what they look like, because they don't all say assessment. There's different words we're using. So we'll dive in and see what those look like. So we have assessment embedded in each lesson. We have the standards for the CSTA standards also listed that they correlate to. We have assessment projects, and then we also have resources for you to take away and use to help you figure out exactly it is what you want to do. So I think I'm going to go and open up the Code Jumper lesson to start with and just do an overview of what this looks like. So starting from the top, I have open a PDF version of lesson 6, which is all about loops. So I'm just going to slowly scroll down so we don't get seasick and go to the overview. So we're going to start with the overview. So in the beginning, the very first page of this, it really helps you understand is what is the point of the lesson. And so it gives you cues on what to look for when your students are going through this. We have our objectives, students will. So for lesson 6, our objectives are understand the loop command in computer programs is a repetition. Okay, so we have a cue right there. Learn how to create programs using the loop command. So those are the things we're looking for and that we can assess. What's nice is each lesson, we have expected outcomes. So we have those outs. So what do we want our students to come out of this lesson? We have ins and outs, and this is our out. So we're hoping all students can explain what a loop command is and why we use it. The first thing we need to look for. Second is most students recreate a program sequence using a loop command. So going from understanding to an action of creating something that has already been given them. And then some students with that more advanced outcome can be creating an original sequence requiring a loop command. So there's those 3 levels that we can look at for students. So then when we're assessing them, we can refer back to this. So almost like a rubric for each lesson that we understand what they need to be. And then we go through, our lesson structure. We also have these key vocabularies that will be really helpful. So then we're bopping along, we're doing our lesson, and at the end of each little section, so the first one is our Unplugged, which Beth is going to dive into a little bit, but I just want to talk about where to find this. So we have closure. So this is this kind of understanding, making sure everybody understands what's going on. So the closure of lesson 6 is tell students that in computer programming, repetitive tasks are called loops. When students use a loop command, the sequence will continue to repeat until it is told to stop based on the number of times they have programmed it to run. So this is kind of our closure at the end. This is what students should know. And then we can go back and look at our outcomes and see did we meet those. So now I'm going to pop down, pardon my scrolling, down to the very bottom of our lesson. And so we have closure again, we have exploration. And then we get to, I talked about standards and check for understanding. So we have our CSTA computer standards that these relate to. We also have the National Curriculum of England and where their standards are, so we can refer back to those and see what we're connecting with. And then there's a closing activity where and check for understanding. So you can ask the students to identify something that involves repetition. So going outside of the program. So this is that extended kind of thinking. And then ask students to think about repetitive tasks that may require multiple loops. So extending that thinking again and moving their thinking beyond just CodeJumper and beyond just a single opportunity, but making it greater. And then we have two statements. Check for understanding. Students can identify a task that involves repetition, yes or no. Very clear, binary, that just yes or no answer. And students can identify and break down a loop into individual steps that need to be repeated. So throughout the lesson, there are opportunities for you as the instructor, the teacher, to talk about and check where your students are throughout this. And you can use different modes, and we'll go into different, we'll show you in depth what the computer science journal looks like and some opportunities and pictures and whatnot later on down the road. Okay, so do I have any questions so far about that? Any clarifications needed?
I don't see any questions in the chat at this particular point in time, and I did double check to make sure that I can let people put things in the chat. So I didn't do that the last time.
Okay, all right. So that's just talking about really where things are, and we're going to go into more depth about with that lesson 6 of what that actually looks like. Okay, Beth, take it away.
Well, so we understand that we want kids to understand what a loop is and how to create a program doing things in CodeJumper as the kind of ultimate concept that they understood what a loop is. But we start with an unplugged lesson in lesson 6, and most of, not all, but most of them start with an unplugged lesson, which means they're taking the concept and we're making it easier to understand based on things in our everyday life. So in the unplugged activity for lesson 6, students are getting into a group and they're kind of brainstorming things that happen in repetition in their everyday lives. They might be something in a classroom, might be like handing out papers. Every day we hand out papers in the same rhythm, or running laps around a gym, shooting a basketball, practicing a piece of music on an instrument. And you might do it over and over and over again. Getting kids to think about those even brushing your teeth every day, like you have a rhythm for starting your day, a sequence of things that you do, but you do it repeatedly until it is done. Identifying what those tasks are so that they can then have a concept to understand what they're doing. They can think real life when they're then doing it in CodeJumper. So yeah, I think I'm going to skim over part of that because I don't want to run out of time later. And then, I know, we can ask them to write in their computer science journal this abstract idea. So maybe they've come up with something like, I'm going to brush my teeth and I'm going to brush every single teeth, the side, the bottom, and then the inside. And then they're going to repeat it until all the teeth are brushed. So they might have to repeat for however many teeth they have. And then we can ask them to put that in their computer science journal. They can either put down the list of ideas or they can discuss, it's kind of open-ended. And so this might depend on you as a teacher, what you're looking for in each lesson. But this one, we want to look to see, do they understand the idea of repetition? That it's going to need to be, the same thing is going to need to be repeated multiple times. And then in their writing, and maybe that's a picture, maybe that's a drawing, maybe that's a retelling of a conversation. You know your students best and kind of how you want to structure that. And sometimes leaving it open-ended is a blessing in disguise, because those kids will come up with some things that really let you know what they're thinking. And if they understand what a loop is, then you can jump to the next part of the lesson, which is, Robin, are you going to demo that?
Yes, I am. And so
Show
Beth,
what
I just put up
to do.
here, just in the lesson for Unplugged, do you want to tell about the activity for the Unplugged and how kind of thinking about that with the boxes? I think that's pretty cool.
Yes. You mean if they were told to move boxes from one place to another?
Yeah. Yeah.
They wouldn't take one box and stop and then until they were told to move another box. They would just move all the boxes until there weren't any left to move. Right? Just like brushing your teeth, you wouldn't finish and just leave that one in the front out. You would brush all of them in the same fashion until it was over. And in computer programming, we have to tell the computer to do all of them. And we need to predict how many boxes there are, or how many teeth they are ahead of time. And that's how we know how many they are. Well, in advanced computer programming, you might be able to figure out when it gets to 0. But we do need to tell the computer, oh, when it gets to 0, or do this 28 times until it is all complete, till all the boxes are gone.
And I like that the assessment piece of this is that we know when to stop. We know if they've figured it out because the boxes will all be moved, boxes or rocks or whatever it is. And that that assessment piece, it's very obvious going, okay, they understand what this because the boxes are all moved, the pile is empty. So we have all those opportunities. Okay, so that's our Unplugged example. We looked at that. Oh, so it's now time, before we go into the co-jumper portion of our event and looking at that, we have another poll question.
Actually, I think this poll question, we need to pause it because I think you were going to go through those examples.
Oh,
And
okay,
then we were
sorry.
going to ask the question, does
At
the
the
student
end.
understand how a loop? So this is like a pre-reading question, guys. It's a pre-reading question. So as you're observing,
Right.
does the student understand how a loop functions? That'll
Right.
be
So
coming up.
put it in a little early. All right. Okay. So now we're going to talk about, so that was the Unplugged. So the way the curriculum works is we have our Unplugged and we get information of their understanding there. And then we move to the guided example where they actually use the co-jumper kit itself, and then they get to put into action that and take to technology what they learned in the Unplugged world. So the objective for the guided example is identify commands that repeat, to be introduced to the loop command and how to put the commands that need to be repeated inside of a loop. And that's the key part, inside of a loop. And then, so we have a guided activity and we're gonna put it into the computer science journal. So first, we're gonna show you what the student did inside the computer science journal. And then I'm gonna actually play the program for you. So I'm gonna open up my Word doc with pictures of where we started with the computer science journal. So this student actually used the computer science journal and used is a print user. So we have a piece of paper, a lined piece of paper, and written in pencil. The top says Code Jumper, and below it says 1, 2, 3, 4. Because the purpose of what they're trying to create in this lesson is a loop, is to make the numbers 1, 2, 3, 4 repeat 3 times. And at the top of the page, the student has written the number 1, and then a 2, and then a 3, and then a 4. And next to that, it says 3 times. So we also have a little math on here. So how are we going to make this work? And then on to the right side, he wrote 12 play pods needed. So he's thinking, going, okay, what am I going to do? How am I create this? This is the project planning portion of the event. So we're prototyping, kind of that design thinking. So what he did was he drew the play pod, and I have to say it's glorious drawings, and they're very well done. The student's a 5th grader. So we have the hub, buttons and all, connected to a play pod, and the play pod's drawn out. Next to that is like a speech bubble with the number 1 in it. And then connected to that is another play pod with a speech bubble with a 2 connected to it. Then a 3rd play pod with a 3, and then a 4th play pod with a 4. And now we're going back to 1. So it's one continuous line. one continuous line of play pods. And then, so it's connected to the play pod that has 4, we go back to 1. And then it goes all the way through. So we have 12 play pods repeating the sequence of 1, 2, 3, 4. So Beth, you worked with this student. Can you kind of tell us the thinking of how they drew this?
Sure. And again, the task was, we hadn't gotten Code Jumper out yet. I had just said, I want you to predict, and prediction is a huge piece of this and what gives me insight into what he's thinking. Predict and tell me what you would create. And I didn't specify that it had to be on the app. I didn't specify it had to be a picture. You could write it in words. This is what he chose to do. And he was predicting, well, if I wanted to say 1, 2, 3, 4, I'm going to connect a play pod each time, and I'm just going to set each one to the next number. And so he has 12 play pods in a line in his head, and he drew them out on the page, which lets me know he understood what the goal was. The goal was to get Code Jumper to say 1, 2, 3, 4 3 times. And technically his little idea works great. If we had 12 play pods, that in theory, that would work wonderfully. This is why in this lesson, we do have them draw first, because we don't have 12 play pods in the kit. And so if you ask them immediately to just create it in Code Jumper, they'll get stuck and frustrated because they won't have enough. And so the prediction level helps me understand, okay, he knows what he's supposed to do. And then the next part lets me know whether he can have the concept of a loop.
All right, so then we move to a drawing of what.
That's the last part. That's the
okay.
extension.
So we're gonna skip down. Here we go. Is this where he's next?
I think I had him build it next.
Okay, here we go. Here we go. There we go. We have a fantastic picture.
There we go.
So we have a photograph of the student. The picture has a little bit of the computer, and it shows the student with his hand on the hub, and connected to that hub is a loop pod with 4 play pods connected to it. And connected. And so Beth, how did we get from the 12 play pods to building it with the loop?
So this student was pretty astute at connecting what a loop was, just needed the introduction of what a loop pod did. And so I actually didn't give a lot of instruction. I let the student sort of figure it out on his own. He figured out that it burped. He had trouble making a connection. So a lot of the work I did was just asking him a lot of questions. And this was one-on-one. So it was really easy for me to be able to do that. And we could hear everything that was happening. I let him get a little frustrated trying to figure out where, because on the loop pod, there are 2 ports, and he kept plugging it into the wrong port. There's a port that extends to the next line in code, and there's a port that finishes the loop. And he finally figured it out and was very proud to then he set all of them, and he naturally was already very used to tracing the code. And so where there were errors, he quickly debugged and figured out that he could change the numbers. He also was savvy enough to want to make sure that 4 was really loud and slow. And all the other ones were quick and fast. 1, 2, 3, 4 was his rhythm. He wanted it to sound like that. It took him a minute to figure out how to adjust the loop pod. He didn't immediately know to turn the dial. Had to point that out, but once he did, he very quickly picked it up and understood what a loop was.
Awesome.
Create it.
So we have some great
pictures. I had him draw a picture of what he did.
Yes, so I'm going to go back up, and here we have a drawing of the loop. And I think having that extra step of not just building it, but actually thinking about the construction, adds to that a level of understanding. So we have a picture of the hub connected to the loop pod, where it says loop 3 times, with those 4 loop pods in there, with each one of them labeled of what they're going to say. And so it's interesting that so he was able to not only create it in Code Jumper, but transfer that with his own understanding onto paper. One
of the things that's actually lets me know the student is pretty astute with figuring it out is that he wanted to express the loop 3 times in a different way. Each pod earlier has a little speech bubble with a number in it. That's what the play pod is saying. But next to the loop pod, I don't know, maybe this was accidental. He wrote the word loop 3 times. He could have written just a 3, but he wanted to distinguish that it was different than that pod playing the sound 3. And so he wrote it out with letters, LOOP 3 TIMES, which is another level of indication that he can recognize in his own work that that loop pod isn't a play pod. It's not saying something out loud right then, or if it is, it's not saying the same thing that the play pod is saying. Right. And you can identify just little things like that, that if that wasn't there, you might wonder if that student was thinking that that was the number 3 that it was going to say out loud. And I didn't point that out. He just naturally did that.
That's fantastic.
Which is just one more thing to look at.
And then I just want to show this last picture because it has a great hack that I really like, because we have real estate on our desks are precious. And so Beth put the computer in the lid of the Code Jumper kit. So all of the pods are to the left, still in their little homes, and the computer is in the lid. It's a little crooked, but I was like, that's a brilliant way to save some space. Always looking for these hacks. And the other thing I want to show you is writing from actually a different student who did the same lesson. And this is the closure. So we had those 2 statements of closure, and I chose to have the students write it versus just saying it out loud. So again, I have that documented information. So the first question is, what is repetition? And to give an example of how you used it in this lesson, the student wrote, repetition is when something repeats itself. In this lesson, we used a loop pod, which repeats the same code a certain amount of times. I know the student doesn't believe in punctuation, so we have none. So, and the second question is, what do you think the advantage is of using a loop? So he actually copied these questions, or he pulled these questions directly from the lesson himself. So this is completely 100% his work. And he answered, the advantage of using loops are you can make the code repeat itself without using so many pods. So there's a lot of really great understanding of and so we have 2 students who are showing their work in different ways. This student chose to write it out. The other student decided to draw it. So there's all these different modalities that we can use. But at the end of the day, they both really understand what it is that they're supposed to get at, and we have the documentation that we need, so we know we can move on to the next lesson, which is loops and sequences. So that's
actually great and intentional, the way the computer science journal is open-ended, because coding there are so many different ways to produce something in coding, and it's all very creative and gives insight to how that student thinks anyway. So excellent examples. Yeah,
those are really great examples. And so what's nice is, so if a student is using like a Braille note or another device, it's totally fine, because all that information is going someplace else. And so it doesn't matter what modality that they're using. I mean, even recording themselves in podcast form is pretty awesome too, to record the information that you can use for assessment. Okay, so we've talked about this, these are just these formative assessments that, checks along the way, but we also have some pretty good in-depth, like end of unit assessments that you can use. And so we have 2, so we have 19 lessons, and the first is the primary. So those really beginning understandings. Oh, sorry, Beth, this is your part. I just got so
excited. You can do this on the next slide.
And so the primary is for our lessons 1 through 8. So you get a good sense in that first half. And then the advanced lessons are the rest of the lessons, which are a little bit more in depth. And so you get a good sense of, do I need to reteach anything from the first 8? Are we good to move on? And then going on from there. So now let's dive into it. So Beth, take it away. Let's talk about the primary assessments, because that first lesson we did was in this first section of lessons.
Well, Beth, before you get in there, let's poll our audience though with our second question, which is in the example that Robin and Beth were talking about, does the student understand how a loop functions? Yes or no. And we've got a few folks that have responded, and everybody is saying yes. So I'm going to go ahead and end that. And I think that gives you guys an opportunity to take a breath, and the audience to recognize that in the ways that you guys sort of demonstrated with the photographs, the journal, and the drawings, that yes, the student did understand what a loop was and its function within the curriculum and within computer science and coding. So now, Beth, would you like to continue along?
Sure, yeah. So when you get to the end of lesson 8, you might take a pause and do a little assessment check to see if students are really comprehending what you've done in all of those lessons. This type of assessment is a little bit different, and it's quite hands-off because it should be very student-led based on what they are understanding. And the basic concept of this is that a student will develop an idea for a computer system they want to create. And they are going to want to include all the things that they've learned. They're going to want to brag about, oh, I know how to use the loop pod. That's just one from lesson 6, but how sophisticated of a program can they make, or do they make? If they choose to do the most simplistic thing, that might give you an idea that maybe they didn't understand some of those other pieces, and that's an opportunity to probe. But in the basic rubric for this, and we'll show you that in a moment, there are 4 different elements we're looking for. The first is planning. For example, when the student had the 12 all in a row, that student was planning on paper, and I could see exactly what he was thinking. I knew what his goal was. And that is where that computer science journal will come in really handy to identify whether what they created in the end matches what they planned, because that can sometimes be a hiccup for students. How their program creation, developing an original CodeJumper program. Did they want to create something? Reviewing and debugging, fixing any errors that might have occurred, again, from their plan that was written down to what they are creating. Are they able to debug? Are they able to look and figure out, oh, this isn't quite what I was initially intending? Sometimes they go back to their original plan and erase it and start over, change it how they want it to be, which is fine, as long as we're watching that process. And then a small presentation with a demonstration of their learning to either a small group or to the teacher. That's kind of open-ended, but just watching that flow. And it doesn't have to take very long. Students are really excited to express themselves with CodeJumper and try all of the different sound sets. So giving them an opportunity. At this point, they should have played multiple times with it, using the different sounds, so they should be fairly comfortable using it on their own. So they shouldn't need a lot of guidance in this. And then let's see. Robin, do you want to, are we showing them the rubric? Do you want
to let's jump in. So let's start out with, before we get to the rubric, let's look at what our assessment is. So we'll go through the assessment plan, and then we'll look at the rubric, and then we'll look at an example of what a student did with the computer science journal to get all the information down. Okay, so I'm scrolling through the plan again. Sorry about the scrolling. So the overview of this, we have, in this activity, students will brainstorm and develop their idea for a computer system they want to create using their prior learning of the programming components. So then we go into depth about their project planning, their instructions, is their brainstorming ideas. So in their project planning page, it's a lot of P's, in their science journal, they brainstorm ideas for a computer program. They explain the purpose of the original program, like why are they doing this? What learning will be evident? And then so they can really show their prior learning. And then they'll be able to discuss with their students, what they found. So again, so this project planning, there's a stopping point here. So it's not just start to finish, but we have all these waypoints that you can connect with your students. So after the project planning is done, you can discuss and talk about and assess where they are in their planning. Mm-hmm. And then when there's a checklist.
Show them the pages for that, Robin?
Yes, so I will show that, and then that's what I'm going to show you next is, let's see here. So that's actually in the computer science journal, which we have here. I'm going to go to the very top of this. So we have, this was created just for the assessment. So for the rest of our lessons, we didn't create computer science journal pages, maybe one or two, really because there's so many different modalities that our students use that we want them to just have the opportunity to create it in the format that they want. Because I think the computer science journal is also a very personal thing. I've seen kids use large print with 2020 pens, using it and just typing a Word doc, just regular print or on their Braille notes. So we wanted to not make it so constraining that it's difficult to really adapt to the needs of the kids. But this one we did, because when we go through this, we'll look at the project planning and you can see that there are really specifics in here. So the first page is a brainstorming section. So this is a fillable PDF. That's the one version I pulled up. There's also an HTML version. So in the project planning, there's a box on the top of the page and it says brainstorm ideas for a computer system containing the following. And then there's an asterisk. You can use the assessment checklist below as you brainstorm to keep track of your parts of your program. So we have sequencing and algorithm, parameters, threads, loops, sequences, and decomposition. So even in this project planning, the students know exactly what they're trying to accomplish. And these are important parts of the first 8 lessons that, and in concepts that we want to make sure that the student incorporates so we can assess their understanding. And then we have explained the purpose of our computer system. And so this student said, the purpose of my computer program is to write a song. Great, so this student wants to write a song. And thinking about that, and when discussing this with the student, I asked him why a song, and what his response was. He's like, well, I can use the sounds that we already have. I can add in my own. And I know I can use multiple threads. I can use loops. I can use sequences and set parameters, all these different things in there that he felt like a song was his best option. He started out with wanting to create a story, but then he changed his mind about that. So now I'm going to hop back to the assessment before we go to the program creation part. So program creation. So this is where the students are actually creating their program. So they go through the process of creating what they want to create, and then they can use their checklist that they have in the computer science journal to make sure they have all the components. So if I hop back to our computer science journal, we have all of these pages for creation, and to make sure that we have everything in there. Again, we have sequencing and algorithm, parameters, threads, loops, sequences, decomposition. And they can describe how each of these is included. And so this student actually needed to do more work on this. It wasn't thorough. So he needs to go back and figure it out, because what he wrote, he checked the boxes for each of these, but he described it as my program has the beginning, middle, and end. I add in sounds on different threads for effect. There are sequences of action, and I have decomposition when I'm building a song. So I'm concerned he doesn't really quite understand all the bits and pieces. So then we can discuss this and see what we need to do to understand where he is in his learning and what we can do to support that. So that's the computer program creation.
Which is also great, Robin, when you see a kid who just like it's a box that should be checked. So I'm going to check it. As the educator, you can walk by later and say, oh, I see you checked, this. Show me where you have a sequence in your program. And if they check the box that they don't have one or can't identify it, that's a clue for you as to what their thinking is.
Right. And then we go through review and debugging and finding where those bugs are, those errors in their program. And so in the computer science journal, we have the opportunity to look at reviewing what we have. And so for the debugging, what the student wrote was, I put my sounds out of order in the sound set, so my program did not work. I had to debug by changing the order of my sound to the correct order. So he put his sounds in wrong. So when he played it, it wasn't correct. So he had to go back and debug and put them in the right order. So that's where we are. And then if I go back to my lesson, and then you have to present your project. So that way, when it's all done and said and done and you're happy with it, then you can play it for your classmates. But he wrote, so we have all these pages that say title, there's a box to write in, or underneath of it is a fillable box. And this is his information about his song. This song represents a happy dog. It has notes and sounds playing at the same time. And so it's called Lucy number 1, which I know is the name of the student's dog. So it's personal, it's meaningful, and the student was very excited to create something about their dog. So that's really how we kind of go through. And then Beth, would you like to take us through the rubric? Sorry, words.
Yeah. Sure. So in the rubric, the project planning would be the first section we would look at to see, could the student predict what they wanted to create? There's 4 categories of options to rate the student, and I'm not going to read every single one. But one is the student provides little to no evidence of their project brainstorming or is unable to explain the purpose of their computer system. And the most points awarded would be 4. The student provides a detailed evidence of their project brainstorming and specific examples to share the purpose of their computer system. So it kind of ranges between 1 and 4 on the planning part. On the creation part, students who might not be quite understanding things yet, student includes only a few of the required features in their program and is unable to explain where each one is used. That was a list of sequencing, algorithm, and parameters, threads, loops, sequences, and decomposition. And the opposite of that, or the 4, would be students include all the required features in the program and can identify and explain where each piece is used. In debugging, and debugging can sometimes be, students can self-reflect about debugging, and also teachers can identify when students are debugging, and they might even prompt that a little bit if they notice a difference between the planning and what they see in the presentation, which is fine after the fact as well, maybe not during the presentation, but just identify, hey, I noticed you had this, what about this, and see what they say, because a lot of times what students say lets us know if they're identifying some of these errors. So if they're unable to provide a verbal or written description about their process for identifying bugs, or in the original program and the steps taken to debug the program are just not seen, then a student would be a 1. A 4 would be students can provide a detailed verbal or written description about their process for identifying bugs in the original program and the steps taken to debug the program. Oftentimes students will say, I use the checklist and I went 1 by 1 and played it, and checked that I had everything on my list. And we know how well some students do at that and others not so great. So it's a good practice for them.
So I have a question for everybody. If I want to throw in the chat real quick, looking at what we had the student write for debugging. So while we're talking, just throw something in there where sorry, I'm gonna go down, where he said, I put my sounds out of order in the sound set, so my program did not work and I had to debug by changing the order of my sound. So kind of in that range of 1 to 4, what would you say the student is at as far as debugging? So just throw it in the chat, put a 1 through 4. And so let's see here. So
rubric back up there side by side, maybe.
Yeah, let's see here. I'll put them.
A 2 would be student attempts to provide a verbal or written description about the process for identifying the bugs in the original program and the steps taken to debug the program. Description is vague or student is unsure of steps to debug the program. That'd be a 2. And a 3 would be student provides a verbal or written description about their process for identifying bugs in the original program and the steps taken to debug. And a 4 was a detailed verbal or written description. Curious what everybody thinks. Are they able to write in the chat?
They should be able to write in the chat, and I realize I've been dropping chats to just us as opposed to the entire audience for the last 40 minutes.
Oh.
So I've got some makeup to do here.
So we have 3s or 4s. We have a 3, a 3.
Rob, and if you were going to analyze this work, what are some of the things you'd be looking at?
Well, when I would analyzing this, I mean, I would definitely, is the student able to describe what the problem is? So Anna asked, what level would we give the student, a 1, a 2, a 3, or a 4 for their description of how they debugged, which the student wrote, I put my sounds out of order in the sound set, so my program did not work. I had to debug by changing the order of my sound to the correct order. So, I mean, I would be looking, well, is the description the problem? We have the problem, which is they were out of order. And we have the solution in there. I had to change my order. So the student understands that there's a verbal, I mean, there's a written description about their, well, I would say what I'm not seeing in this is identifying bugs in the original program. Because I would, to make it really a strong 3 would be, I played my program and it was out of order. And so I debugged by realizing my sounds were in the wrong order and then had to change them. So the part that I feel like is missing out of this is in his description is how do you know he put him out of order? That part of that process. But he did take the steps to fix it. So I would give him a strong 3. How about you, Beth?
Yeah, probably the same. I think verbalizing with the student and seeing when the student talks to me, if I could understand exactly what was wrong before and how he fixed it.
Yeah.
Because we're identifying their debugging, we're trying to help with that communication, but we don't want it to get too bogged down in how he communicates. So making sure he somehow let me know what the process was and he was able to do it on his own without a lot of help, without needing a lot of prompting, and was able to give a description of what was going on. So I would say a strong 3. I think a 4 might give more information, like, oh, the dog barking sound came before the cat, or, you know, and so I had to switch it, a more detailed example.
Great.
4 minutes left. Yes.
Yeah.
Thank you.
Okay. So
Really.
we can talk about this stuff all day long and we have to be reined back in.
I think that's also something where it's fun for teachers to talk to each other about it. And so fine tuning your process and finding other teachers to chit chat about it can definitely help.
Yeah. So we have our last poll question is, and this goes into the chat. What do you want to know about your students' progress with the computer science curriculum developed for CodeJumper? So what do you want to know about your students' progress? So if you could write that in the chat, again, what do you want to know about your students' progress with the computer science curriculum developed for CodeJumper? And just real quick, we have in the PowerPoint, we have a list of resources that you can find all sorts of information. We have CodeJumper, we have code.org, where you can assess, there's a section on assessing and checking student knowledge. Make Code has teaching with Make Code, which has some good options in there. The CTSA standards, and CS for All has a program called Script, which is helping you get started with computer science. So those are 5 resources that you can use to kind of learn more about assessing and about how to use this, learn and teach computer science with your students. So I'm not seeing anything in the chat about, oh, here we go. We have, if he or she can feel confident enough to feel that he or she is an independent user and limit the teacher's presence. Yeah, no, that is great. Absolutely. That's wonderful.
So I mean, I would evaluate that based on how frequently you're needing to intervene. too. You know, if you're having to intervene a lot with your students and really step by step for them, maybe they're not grasping the concepts. That's where sometimes going back to those unplugged lessons, if the student is relying heavily on the teacher and isn't as independent yet, some of those unplugged lessons are great. What do you call them when you're, lining up at the door, and some of those in between times in the classroom, or as an opener, icebreaker. A lot of them are really fun, and they just help solidify the concepts. And the more the concepts are solidified, the more independent the students will become eventually.
All right, and real quick, the other comment, I want to get our elementary kiddos started on the concepts early to eventually track how many move them to a more advanced coding class in high school. Exactly. Yeah. All right, Jim, I think you're up next.
Yeah, so as we wrap up, just some of the things that we've discovered is that assessing through things like screenshots and recording and journaling, that the first 14 lessons include everything from vocabulary to offline activities and exploration activities, and then finally that the assessment is comprised of that project planning, program creation, review and debugging, and a project presentation. So